catabolic decomposition reactions, where is something split up. So A and B becomes A and B. So a molecule, a larger molecule, A and B together, AB, is split up to become a single atom, ion, or if it was a larger molecule, a molecule also, and another one, B. So AB becomes A and B. And all the ones where this happens with decomposition in the human body are called catabolism. That is according to Georg Tuga and Sandra Grabowski's Principles of Anatomy and Physiology book on the page 37. Hi and welcome. I am trying to learn biochemistry. Today, decomposition reactions, catabolism. And after we've done that, we're going to do hip training. And if you participate in the hip training, then it's pretty harmless. Decomposition reactions, catabolism. After types of chemical reactions, first we have to talk. After a chemical reaction takes place, the atoms of the reactants are rearranged to yield products with new chemical properties. In this section we will look at the types of chemical reactions common to all living cells. Once you have learned them, you will be able to understand the chemical reactions discussed later in the book. Decomposition reactions, catabolism. In a decomposition reaction, large molecules are split up into smaller atoms, ions and molecules. Okay, a large molecule consisting out of multiple things. We forgot that we wanted to read in this part of the thing about molecules. So they split it up into large molecules, and now these molecules are split up into smaller atoms and smaller ions or molecules. A decomposition reaction is expressed as follows. AB molecule breaks down into A and B. So it was AB together, and now we're just A and B. For example, under the proper conditions, methane can be decomposed into carbon and hydrogen molecules. Methane is CH4 and that breaks down into C and two hydrogen molecules to H2. Okay, we wanted to read the thing with molecules, there's something with two, but in basics it is together, it is A and B, and it's split it up, now it's A and B. All decomposition reactions that occur in your body, we're talking about a human being, are collectively referred to as catabolism. Okay, whenever something is not composed together but decomposed or divorced, that is called catabolism. Overall, catabolic reactions are usually exergonic because they release more energy than they absorb. So after an exergonic reaction, there is less potential energy in the products. The series of reactions that break down glucose to pyruvic acid with the net production of two molecules at ATP, adenosine triphosphate, ATP, adenosine triphosphate. So the series of reactions that break down glucose to pyruvic acid with the net production of two molecules of adenosine triphosphate are important catabolic reactions in the body. These reactions will be discussed in chapter 25, here in chapter 2. Okay, glucose is something that is more or less eaten, that is broken down to the pyruvic acid, and there's also happening with two molecules of adenosine triphosphate. And the breaking down of glucose into pyruvic acid and two molecules of adenosine triphosphate is important catabolic reactions, so a reaction where things are decomposed, split up, divorced in the human body. A key feature of the body's metabolism is the coupling of exergonic reactions and endergonic reactions, so that energy released from an exergonic reaction is used to drive an endergonic one. In general, exergonic reactions occur as nutrients, such as glucose, are broken down. Some of the energy released is temporarily stored in a special molecule called adenosine triphosphate, which will be discussed more fully later in this chapter. If a molecule of glucose is completely broken down, the chemical energy that was stored in it in its bonds can be used to produce as many as 38 molecules of ATP, of adenosine triphosphate. So 1 molecule of glucose is enough for 38 adenosine triphosphate. Is it possible to calculate everything so exactly? Must be. The energy transferred to the adenosine triphosphate molecules is later used to drive endochoric reactions that lead to the building of body structures such as muscles and bones. The energy in adenosine triphosphate is also used to do mechanical work such as occurs during the contraction of muscle or the movement of substances into or out of cells. Okay, decomposition reactions, that is catabolism, and it's about having a molecule which is split it up, which is an exergonic reactions, and at the end there's less energy in the product, but there is sometimes energy stored in adenosine triphosphate, which can be used to construct muscles or to build bones or something. That was the biochemistry part. If you were here for biochemistry, you can go directly to the next part of biochemistry, where we're going to read on. If you stay here and participate in the Hiptraining methodology on this. The feet are standing together. One toe opens the other one. Here, and so on. As far as you can go, and then again. This time, stay down with the knees. So go into the knees. Hip width apart, a bit down into the knees, flex the legs, press them together, straighten one leg. Bend it again, press together flex, straighten the other leg. Legs a bit aside, down into the knees, flex, press together, out to one side. Leg. The middle. One leg up and leg to the side. Breathe in. Back into the middle and down. The other leg up to the outside. Breathe again in. Into the middle and down. One leg to the side of the toes. Lift it off the ground. Place it again onto the ground. Other leg. And now one hand on tummy, one on lower back, and lift one leg up. Flex the foot as high as possible. Try to bring it higher. Control with the hands that you don't fall back. Try to bring the leg higher. And bring it up. The other leg. And pull the leg up. And stand good on one leg. This can go onto the knee. Turn over. Now down. Turn controlled over. Up. Other leg. Stand good. Turn over. Down. Again over. Up again. And the clock. Stand good. And reach. Always with a knee to imaginary 90-minute intervals on an imaginary dial. And the other leg at 12 o'clock and 1:30 and 3 o'clock, 10:30 and 9 o'clock, 6:30, 4:30 and 3 o'clock. And now, one heel onto the ground. Don't do this if you're pregnant. Lift the heel off the ground, place it again onto the ground. The pet exercise. And with the other leg. And now, the toes are pointing to the outside, and breathe in with the arms up. Breathe out, sink down. Put the hands onto the ground, come with the back up, and roll slowly up again. The top of backwards shoulder roll. The illusionistic down sitter. Again, breathe in the arms up. Out and down. Hands onto the ground, with the back up, and roll slowly up again. The top of backwards shoulder roll. And now, the seesaw airplane. Arms to the side and bring one leg back. And then again. And again. And now for hiding airplane. First into the airplane, and then pull the knee in and out. And back into the upper leg. First the seesaw airplane, the airplane and seesaw back. And now into the airplane. And a hiding airplane, the knee in and next side. Breathing out down. The trunk catalyst and again out. In and out. And out. Breathe in and close the legs. Breathe in and out. It was the hip training. I thank you very much and until next time.